Hello. I'm not going to give a full lecture for this module where we're learning Prolog, but I did want to at least set things up for you with a few very quick words about how this fits into the broader context of what we've been doing this semester. So these are just a couple of very brief slides about logic programming and an introduction to Prolog. So most of the languages that you have used up to this point have been what we call procedural languages, where you define the solution in terms of algorithms or sets of steps that describe how to solve a problem. So most widely used languages fall into this paradigm, but it's not the only paradigm, right? And we've seen at least one other paradigm. We saw functional programming, where we don't define the solution in terms of a set of steps, but rather in terms of inputs and outputs. We wrote functions instead of algorithms, essentially. And so, there are a lot of languages in this vein, although they're not nearly as widely used as procedural languages. So Lisp and Scheme are some historical ones, and then of course Haskell is the one that we used. But there are other paradigms as well, and one that has been useful in certain subdomains of computer science in the past is declarative or logic programming. And so here we're not even going to define functions anymore. We're just going to be defining solutions in terms of logical statements. So we're going to be defining particular atoms and then the relationships between those atoms and making inferences. And so this is why we're learning Prolog, because Prolog is a declarative or logic programming language. So it's based on first order predicate logic. So basically, it has an inference engine. So you tell it things, you tell it facts, and you tell it rules, and then it uses inference to infer the truth about various queries. So basically, you make a database of rules and facts, and then you make queries to that database, and Prolog takes care of figuring out the result of your query. So here's a quick example in Prolog. So here we are defining a predicate called mother, and we as humans, we define how to read these predicates. So here we're going to define this as meaning Alice is the mother of Sally. We could have done it the other way around and said that, well, this means that Alice has mother Sally, which is what we'll do in most of the lab and the project. But for here, I wanted to keep things simple. So we're just going to read this as Alice is the mother of Sally. So that's what this means here. Similarly, this means that Tom is the father of Sally. This means that Tom is the father of Erica. And this means that Mike is the father of Tom. So these are what we call facts. These are just relationships between these words, which we call atoms. Down here we have some rules based on that we can use to infer things based on these facts. So first of all, we'll define a new predicate called a parent. So we will say that X is the parent of Y, and notice that we're using uppercase characters here. So all of the atoms begin with lowercase characters, and then all of the variables that we use in defining our rules are defined using uppercase characters. So X is the parent of Y if, so the colon dash here sort of reads as an if X is the father of Y. So in other words, if we know that X is the father of Y, we can also deduce that X is a parent of Y. There's also a section definition of parent, however, so we can also infer that X is the parent of Y if X is the mother of Y. So there are two different ways of inferring this parent relationship. So for instance, we would be able to infer that, Tom is a parent of Sally, right? We would also be able to infer that Alice is a parent of Sally. So here's a slightly more complicated rule. So X is a sibling of Y if, and now you'll notice that we have two clauses here. So both of these clauses have to be true in order for us to be able to make this inference. And here we've also introduced a third variable here. So X is a sibling of Y if Z is a parent of X and Z is also a parent of Y. So in other words, this is basically saying that X and Y are siblings if there is some third element Z that is the parent of both X and Y. So for instance, we can infer that Sally is a sibling of Erica because they have a common parent. And in fact, in this case, the common parent would be Tom. And then we would not be able to infer that Alice is the parent of Erica because there's no set of rules and facts that would allow us to deduce that. So that's just a quick, very short introduction to Prolog. Your real full-length introduction to Prolog is in the lab for this week. And so you should go ahead and start on that as quickly as you can.